Hello Liz, this format is quite different, I'm not gonna lie. But for today, we're going to be doing lesson 2 from my science unit plan, the balloon power car, which explores the topic of Newton's 3 laws of motion. It's just me today, so that's definitely a bit different, but I'm going to try my best. So normally I would start by greeting the students at the door, getting them seated, and then introducing the activity. So that is where I'm going to start today. Good morning, grade 5s and 6s. Thank you all for sitting so quietly and quickly. We're going to continue where we left off last class, that being exploring Newton's 3 laws of motion. Specifically, we'll be looking at Newton's 3rd law. Do any of you recall what that law is? Yes, for each action, there's an equal and opposite reaction. So we're going to watch a short YouTube clip explaining this and demonstrating it in action. So I'd like you all to sit quietly, watch the video, and please do not disrupt your neighbor. Enjoy the clip. Hello class. So after watching that video, what are some things you learned or saw? Please raise your hand. Some things I saw was that there's an action and a reaction force, but although these two forces are moving opposite to each other, the amount of force applied is equal, which allows a balloon to sail through the air if released, or in the case of this video, it allowed the man to sail across the concrete using nothing but a skateboard and a fire extinguisher. So we're going to be testing this law for ourselves today with a balloon-powered car. So class, to make our balloon-powered car, we'll be using sticks, straws, tape, a bottle, a balloon, hot glue, lids, and simply Newton's 3rd law of motion. So I'd like you to circle around while I demonstrate the car I made at home. Class, this is my balloon car. So I'm going to blow it up and demonstrate how Newton's 3rd law works. So the balloon is full of air right now, and if we let go, the air will propel through the straw. And this force, pushing this way, out the straw, allows the car to move forward. So as you're about to see, I'm going to put this on the ground, and you can see this in action. So it's time to make your own car. I'll call you up table by table. You'll come up, grab your material, sit back down, and you'll have the next 20 minutes to work on your balloon-powered car. class, the 5 minutes warning is up. It looks like most of you were able to finish. Not to worry, we'll have more time to work on them if you're not quite done. So we're going to lamp at the door in an orderly manner, quiet, no touching. And we're going to meet out in the hall to test the distance of our balloon-powered cars. So everyone line up, and I'll meet you outside. So we're going to start with Team Brien. Please blow up your balloon and line it up. So, as we saw from our test, your car did not move at all. So, thinking about what we learned this class and last class, what could be the issue here? One issue that comes to mind is that there's too much friction on your tires. So, when revising your car, think of ways in which you can reduce that friction. I'll be coming around desk to desk with some suggestions on how we can fix this little friction problem. When looking at the design of your car, spin the tires and tell me what you feel. There is quite a bit of friction. So what way can we reduce that friction to hopefully make your vehicle work? One idea we could do is that instead of having the tire connected to the straw, place a piece of wood in the straw and have the tire connected to the wood instead of the straw. The tire is able to move more freely and hopefully propel your car forward using Newton's third law of motion. Class, time is up. So we're going to step back outside into the hallway and test our new and improved cars. Hopefully this reduced amount of friction will help your balloon-powered car actually move this time. So let's line up in an orderly fashion and head back outside. With our redesigned cars, we're going to try this test again and see if we can get further this time. So let's start with Team Brien. So welcome back to class. So I want to end today reflecting on what we saw and learned today. So feel free to raise your hand if you want to share. So what I learned today was Newton's third law of motion, that being, anyone? For each action, there's an equal and opposite reaction. In the case of our balloon-powered cars, our balloons were filled with air and connected with a little straw. All that force pushed out in one direction, and because every action there's an equal and opposite reaction, the act of that force coming out the straw caused the car to propel itself in the opposite direction, because at the end of the day, these two forces are equal, although in an opposite direction. These forces being an action force and a reaction force. And although not all of our vehicles worked today as planned, don't worry, feel free to take them home and we can test them out again at the beginning of class tomorrow. So, thank you for listening, and this is the end of my video. Hi Liz. This is a little bit of a reflection I'm going to take on in my video, just to talk about the experience. Yeah, it was pretty different. I'm in my room, obviously. No audience, just myself, a camera, and my reflection in the camera. A bit daunting to say the least. You'd think this experience would be easier. I'm in the comfort of my room. There is no audience. But if anything, this was more difficult than teaching in the classroom. And even though it was a challenge, at the end of the day, I appreciate a good challenge. I can't grow unless I challenge myself. And I learned a lot doing this. I learned that there is value in testing an activity before actually doing it in the class, because I ran into quite a bit of complications, which will be in my write-up. But at the same time, I'm happy at the opportunity to do this in this format. A bit of experimentation never hurt. And I guess it's time to edit this video. So wish me luck. I'll be hearing from you soon. See you, Les. Dang it, Liz.